I have started uh, recording right now. So welcome to the NPTEL weekend tutorial of digital circuits. The course code is ee147. This is offered by Professor Shantanu Chattopadhyay from IT Kharagpur. Myself, Sai Shubham. I am pursuing my PhD in the Department of Electrical Engineering from IT Kharagpur. So let's solve some few questions related to VHDL, Verilog, and 8085 microprocessor. So the first question says, what programming language has been utilized in the development of Verilog HDL? So this is a pretty straightforward question for you all. This is look at the question. The answer is C programming language. If you There is nothing to solve in this question. If you know this question, then this is actually like in this question, this is a memory based question. You do not have to apply anything, obviously. So the answer is C programming language. C language, as mentioned here. The next question is, what programming language has been utilized in the development of VHDL? So the answer to this question is A, ADL language. So hardware, so VHDL stands for hardware description language. Okay, so this hardware description language is based upon some predefined coding language, right? So in this case, Verilog you use C. Here in this case, you use this ADL language. So what signals? So moving on to the next question. What signals should be included in the sensitivity list of the process construct for the given combination circuit? So a hint I would like to give that sensitivity list is the list of all those signals which when changed has the like all those signals which when changed can impact the output. Okay. So if you are writing a code and if you want that as soon as a particular set of my input signals change, that change should be reflected in the output. So all those relevant input signals should be kept in your sensitivity list. Fine. So I think you can answer this question. Sensitivity list implies that those signals must be input signals because you cannot make it sensitive to output. So in this case, the answer is A. That is A and B. Moving on to the next question. Which of the following statement is true? So answering this question, a hint I'd like to give is that as in C programming language, you have all the variables, you update the variables, you perform operations on those variables, and you get the output which is contained in those variables. This is different as compared to a hardware description language in which the concept of variables and signals are different. In computer coding language, your inputs are stored in variables and there are other variables which you use for iteration purposes, right? Or for temporary basis, you use them. In case of hardware description language, your inputs are basically your signals, which can only take the value 0 or 1 or a particular z state. Okay, it depends. And you have a set of certain variables which you use to do some process, right? A process can be like a particular operation you are performing on signal, suppose and operation or operation. So if you want those operations to be iteratively performed over multiple cycles, okay, so you can use variables. You can in define a variable I that is equal to 0 and iterate for multiple cycles. Okay, so in that case, there is the importance of variable. You cannot take a signal and iterate it because signal cannot be iterated. You have to understand that signals have a physical implications, whereas variables are in the virtual world. Okay, so in this case, whenever the signals are defined, then only you can start some event related to signals. Event of any signal is started after you use the uh, begin command and the end command. So every operation related to the signal should be inside the begin and end. And a signal can only be used if the signal has been defined. Otherwise, it will give you an error. Okay. So in this option, this question says that which of the following statements is true? Signals don't have notion of event scheduling. Definitely, signals have the notion of event scheduling because signals are time continuous. Okay, so they have to be scheduled. Second is that variables follow the notion of event scheduling. No, variables are just virtual constructs. They have nothing to do with the physical implications. Okay, signals follow the notion of event scheduling. Yeah, so this is true. So option C is true. Okay. Moving on to the next question. What is the instruction set size of 8085 microprocessor? So by instruction set, it means that what are the different operations your 8085 microprocessor can support. Okay. So there are so if you provide two different numbers to 8085 microprocessor, you would want them to be added, to be subtracted. Okay. There are some other basic operations such as shift left, shift right, and so these are the various operations that you have. Okay. So what is the instruction set size of the 8085 microprocessor? So what are the different instructions that you can feed to the 8085 microprocessor? That's the question. So the answer to this question is, this is a memory based question. So the answer to this question is A, 74 instructions. Okay. Moving on to the next question. Which of the following is not a part of 8085 microprocessor? So the answer to this question is D, GPU. So inside your 8085 microprocessor, you have register bank. Okay, so register a temporary memory that is very much close to your CPU. So whenever CPU has to fetch any data that is being used multiple times, it will store it inside the register, not in the RAM, not in the RAM. Okay, so this is your register. This is your control unit. Okay, something has to coordinate with the register and the arithmetic logic unit. So ALU performs all the any logical operation that is supported by 8085 microprocessors, such as addition, subtraction, shift, left and right, load operation, store operation, everything is done by the ALU. Okay, and it is controlled by your CU. So this is known as your central processing unit, right? This entire thing is the CPU. So you have the control unit. So GPU is a new thing. Okay, so this is not a part of your 8085 microprocessor. So next question is that what is the primary function of a microprocessor assembly language? To speed up the program execution, to program microcontroller devices, to communicate with hardware devices, to provide a low-level programming interface. So the primary function of the microprocessor assembly language is to see. So in case of to speed up the program execution, so program execution speed is dependent upon the clock speed of the CPU, right? So the faster the clock is, the faster, the higher the frequency of the clock, the faster it can execute the program. So this is not the correct answer. To program microcontroller devices, so this is the correct option, because assembly language is used as an interface between your high level language and your machine language, right, which the machine can understand to communicate with the hardware devices. Um, Not exactly, not to just communicate, but we have to program it to provide a low level programming interface. So this actually looks correct, but the most appropriate answer will be B. So which component is responsible for converting assembly language code into machine code? So the hint lies in the question itself. So the answer is C, assembler. So assembler is used to convert the assembly language code into machine language code. Okay. Compiler is used to convert high level language into assembly language. So in the context of microprocessor assembly language, what is the mnemonic? So mnemonic is basically the different kind of instruction set that we have. Okay. For example, different operations in the instruction set we have. Suppose add, subtract, shift, load, and store. So they are written in form of mnemonics. Add is written as ADD, subtract is written as SUB, load is written, I think, LD, store is written as ST, shift is written as SR or SL depending upon whether it is shift right or shift left. Okay. So these are the short forms that are used. Fine. So this is a type of symbolic code to represent an instruction. So the answer is C. So 8085 microprocessor. The next question is 8085 microprocessor is a dash bit general purpose processor. So it has a 4-bit data, and rest of the 4 bits are actually used to store the instruction of it. So in total, it is an 8-bit general purpose microprocessor, right? Because if it has, so the input to the microprocessor is an 8-bit data, of which, of that complete 8-bit data, 4 bits are for the instructions and rest 4 bits are for the actual value on which it has to operate. Okay. So the answer is B. So what is the total number of pins in 8085 microprocessor? So again, this is a memory based question. The answer is 40. There are 40 pins. Next question is, what is the purpose of ALU in 8085 microprocessor? So let's go by each options. To store data temporarily. So that's the job of your registers. To manage program flow. So that is done by the control unit. So to control memory access. So this is not actually done by ALU. This is also done by control unit. This is done by control unit. This is done by register to perform mathematical operations. So that is, this is done by ALU. So the answer is A. So what is the data bus width of a 8085 microprocessor? So again, the data that we need to process has to transfer from the bus. So the bus width should be at least the size of the data taken by the microprocessor, right? So I think you can answer this question. So the answer is D, 8 bits. Moving on to the next question. Choose the entity declaration for the following circuits. So this is a BSDL code. Okay. So I will give you some time to think. this question, entity is basically the name of your module. Okay, so this is your name of defines name of module. So n we are input, so this is defined by in. Sum is your output, so it should be out. Okay, this represents if it is bit, byte. I think there is other orientation, that is your boolean. So in this case, this is in bit bit, out bit bit. Okay, so I think the answer should be this B. Okay, so that's all question I had for today. So I am stopping the recording right now. If you have any questions, let me know. So we will do, suppose we are going to make simple and get what we will do it. Okay. So NPTEL inputs A, B, and architecture does the original A and B file. Now we will look how they start the multiplication here. For example, if the first time Y is there, it will be A when the select is 0 and it will be B when select is 1. And it is Y equal to A select R plus B select. So first we need to take 3 nodes. Let me actually use So what are the important operations? Important operations are sum is A, so B, carry is A and B. Therefore,